Hello, everyone, and welcome back to episode 13 of Nelson's Corner. Tonight we're going to be continuing on with the card game engine. We're going to be looking at some more architecture. This time around we're going to be looking at pre-game architecture. Now, before we get started with content, let's go ahead and take a moment to welcome Mr. Zach Bear.
Hello.
And Mr. Smooth Butter himself, Nelson.
Hey.
Hey. All right, so last time around we spent a little bit of time talking about the architecture from, I guess you could say, a big picture point of view, and that's what we've got up here on the screen. Now what we're going to do is start talking about the pre-game architecture, and that has been something that you've been working on quite a bit lately, right?
Right. One of the things that we haven't really even talked about yet is the concept of getting the card definitions organized in such a way that they can be brought into the context of an actual game.
Okay.
And the way that we can organize those card definitions into decks.
Okay.
And I kind of decided that that would be the first sort of problem I would tackle, not only because it's a requisite to getting a fully functional game working, but also because it's relatively it doesn't have very many ties into the runtime side of things. It's a fairly self-contained system.
Okay.
So hopefully this will just be a short thing going over how that's all laid out. I guess the first place to kind of start is the card definition interface.
Okay.
And the card definition interface is probably the most important part of the system.
Mm-hmm.
Because, like I said, that's the entire responsibility of the system, is to get these iCard definitions instantiated and created in such a way that we can then turn them into cards that are actually on the battlefield or in your library and whatnot. So the iCard definition is pretty much the only sort of interface in this entire system that's going to have any knowledge of the runtime state of the system, because, like I said, every card definition is going to be paired with a class that's responsible for the runtime behavior of a particular card.
Okay.
And the kind of things that a card definition contains is an ID, which will be a GUID, and I'll talk about that in a second. A name, its color, its card type, its subtype, its casting cost, its flavor text, its artist, and what set it's in. And the reason I chose to throw set in, by the way, is so that we can get images going, because there are multiple images depending on what set a particular card is from.
All right.
Which we won't be redistributing in any way. You'll just get to watch us use our awesome images.
Well, there you go.
That I obtained magically. So we have the card definition, and we have this class that I call currently the card game environment.
Okay.
And the card game environment is sort of the entry point into this entire system. Basically, his responsibility is to, before the game even starts, he is going to aggregate a collection of objects, a collection of iCard definition objects. That's his purpose. He gets those collection of iCard definition objects. Then he gets a listing of decks and different decks. And a deck is simply, it's a deck.
Is it its own class?
Yes, it's an IDEC interface.
Okay.
An IDEC interface has a collection of iCard definitions. And in addition to that, it also has a count for how many iCard definitions are in a particular deck. So, for example, you could have a forest from the Zendikar set, and you may have 20 of them in your deck. So the deck is a sort of way to organize your iCard definitions into something that's going to be used to construct the playing field once we get to that point. So the iCard environment, the way that I have things set up is I have the concept of iCard collections. And a card collection is sort of this idea that I'm playing with to solve the issue of how do we uniquely identify cards when two players, again, I'm thinking towards networking, because we have to keep that in mind from the start so we don't code ourselves into a corner. Two players get together. We need to be able to uniquely identify the concept of a card between those two players, and they're going to be on different machines. They're going to have different collections. Not different collections in the sense that the cards are going to be different, but different collections in the sense that they're going to be cards, objects sitting on their local computer. or card files sitting on their local computer. So we need a way to correlate a card. And so I chose this iCard collection as a sort of abstract idea where an iCard collection contains a bunch of iCard providers, a list of an enumeration of iCard providers, or whatever I called them. I called them something different, I think. iCard collection or iCard definition provider. So an iCard collection contains a bunch of these providers. And each of these providers, they have one responsibility, and that is to spit out a bunch of iCard definitions.
Now, are you following along with Zach's drawings?
Yeah, I'm...
Make sure that...
Yeah, because
you
can direct me. You can have me move stuff around. And...
Yeah, make sure what he's drawing is correct. Don't let him just start drawing stuff that is not correct.
Well, right now I'm just trying to get the classes down as he mentions them. How they connect is something I'm not sure about yet.
Okay. So you have the iCard collection, which contains iCard definition providers.
Now, now you said that was just an enumeration?
Yes, the iCard collection contains a bunch of iCard definition providers.
Okay.
And so I guess if you want to organize this in how I'm thinking about it in my twisted head, you should put the iCard collection where the iCard definition is, and then scoot the iCard definition providers to the left of the iCard collection, and then scoot the iCard definitions to the left of the iCard definition providers.
Try again.
Yeah, you failed miserably.
Yeah, wow, you failed that really hard.
You said slide this guy over to the left, and then slide this guy to the other side to the left.
Okay, replace iCard collection with iCard definition. So just yank him out.
Let me just erase all these guys for now, because that'll make things a lot easier. Let's just assume we don't need all this.
Sorry about that.
That's okay. No problem. No problem.
I'm still working on establishing telepathy.
Okay, who goes first?
Okay, so all the way on the left is iCard definition.
Sure.
To the right of him goes the iCard definition provider.
There we go. Yeah, I gotta make my box a little smaller. Apparently this isn't as transparent as I thought it was just a second ago. But that's okay. All right.
And then to the right of the iCard definition providers goes the iCard collection. And to the right of iCard collection goes the card game environment.
Okay.
And then under the card game environment goes the iDeck.
Okay. Sure.
So, yep, that guy gets yanked up there. Okay, he's yanked right there, and the iDeck goes under the iCard game environment. Okay, so there's a bit.
Now remember, you can guide Zach. So I just want to make sure that our drawings accurately represent what's in your head.
Yeah, and for some reason I'm thinking right to left today. So basically, what we start off is this card game environment. He's like the main. Actually, you're gonna hate me, Zach.
You need me to reverse the whole thing.
Could you just?
You are a person. You are smooth butter.
Should he grab both of those?
Just put that there, and then take the iCard collection, put them to the right to the iCard game environment.
So yeah, reverse the whole thing. Yes.
See, again, I just got this right to left thing in my head for a second.
Yeah, and we're all going to suffer for that. Basically.
And then I realized that Western culture is generally thinking left to right.
Yeah, of which you are a member. Just by the way, you do live in a Western.
You were defending it just earlier.
just moments ago, actually, in the relative sense. So yeah.
Okay, so that should make more sense to people, hopefully. So the card game environment has these collections. The collections have the providers. The providers don't necessarily have iCard definitions, but they provide them. They can spit them out. I just want to kind of make that distinction.
Okay.
Sort of. Because an iCard definition provider...
Should I be connecting these guys together?
It's kind of implicit the way you have it look organized.
So be it.
So the iCard definition provider is really interesting because his responsibility is to spit out iCard definitions and shoot them all the way back to the card game environment. So the card game environment has this collection of iCard definitions that are provided by the iCard definition providers. Now the iCard definition providers are interesting because, like I said, they spit out objects that implement iCard definition, and they can do so with any means that they they deem necessary. Meaning, we could have a C# card definition provider. We could have a .NET precompiled assembly card definition provider. We could have an F# card definition provider. We could have a Boo card definition provider. It's a really abstract concept. Basically, they just spit out classes that implement iCard definition. So this is how we're going to how we're going to implement multilingualness with an emphasis on Boo particularly. But like I said, there's no technical limitation that we can't also write cards in F# or C# or VB.NET or Iron Python or Iron Ruby.
But you're planning a provider in C#, aren't you? A C# provider?
Yes.
Okay.
And then I'm also planning a precompiled assembly provider as well, so you can have all your classes in a already defined assembly. We could also write an iZipped definition provider that grabs stuff out of a zip file. It doesn't matter. The point is that it's abstract. This data can come from anywhere, including, and this is important, a network connection.
Okay.
So this would be, if we go down the route of doing it this way, and there's many ways to do it, I haven't quite gotten also my head around in which way we're going to be handling this. But if two players connect, we could, in theory, have an iNetworked card definition provider that just literally yanks the card definitions directly from the host and shoots them back and slingshots them back into the card game environment. So does that kind of make sense?
Mm-hmm.
Yeah.
Okay, so the card game environment has all these iCard definitions available to it, and also has these iDecks available to it. And again, the iDeck is just like what you would think of a deck. It's a collection of iCard definitions coupled with, or in the functional sense, tupled with, a count of how many of those cards should go in that deck. So like I said, you may have a iDeck with 10 forests.
Okay.
So, yes. Basically what happens at the end of this, the end goal of this entire system is to get these iDeck interfaces and shoot them off to the runtime. And every single iCard definition, like I said before, it's going to be an abstract factory. It's going to have a create runtime method on it.
You got really quiet.
Well, I'm just watching you, right? Yeah, so there's a create runtime method on the iCard definition that will, like I said, it follows the abstract factory pattern. That it's going to just shoot out, like I said, the actual physical cards. So if we have an iDeck with 10 Zendikar forests, when we start the game is going to say, okay, iDeck, give me a card that you have. You have a forest. Tell me how many of you have of them. You have 10. So for each, or for var equals 0, var I equals 0, I smaller than how many cards are in that particular deck of that type, create a new instance of that forest, and then stuff him in my runtime representation of the library.
Okay.
Okay.
So was that
Yeah.
a clear
Yeah,
explanation?
but except for you did the exact same thing that you did in coding earlier. Same mistake. You forget your iterator. You forget to actually increment your iterator.
Well, what I'm going to do, since
It's
we've
pretty
already kind
funny.
of discussed this, I'm just going to kind of simplify this to...
Just say for each from now, Nelson.
yeah, exactly.
That's pretty funny.
I'm sorry, I'm not too much of a procedural coder anymore. For loops confuse me.
I understand.
Yeah.
Give me a link query.
He's too smooth for that.
Okay, so yeah, that's kind of how it works. As far as the architecture, there's not too much more to. Well, I'm sorry, Zach. I could throw at you all the tiny little things like the card type enumeration, the casting cost class, blah blah blah, but that's sort of irrelevant for how the data flows.
Nah, I'm going to improvise. We're just going to grab all this stuff, and we're just going to kind of bring it front and center so we can kind of look at it.
So this, so yeah, the entire point is you instantiate a card game environment. You load up collections. Those collections, in turn, load up definition providers, which create definitions. Those definitions are stuffed into decks. Those decks are sent to the runtime, which use the definitions to instantiate the runtime representation of every card.
Cool. Very cool.
Now let's balance it out with a smiley.
So in the next video, we'll just keep this one short, Nelson. There's no reason to push into anything else if this is all of the architecture, because I know you don't have the architecture for the actual runtime completely worked out yet. You've got ideas, so we can wrap things up here. But what I'm thinking, or what I'm curious about, is in the next video, do you want to go ahead and start getting the projects set up and start putting all of our abstracts together and all? Or what are you thinking?
Well, I think the code for this entire thing that we just kind of diagrammed out is relatively small. It's only like, I think, 300 lines long or so. Mm-hmm. And it's very isolated from the runtime. So we can actually implement a working application that uses all this. And we could also take this as an opportunity to get into Boo as well. Okay. That sounds awesome. Well, then we'll go ahead and wrap this video up. And thank you, Nelson, Zach, and all of our member sponsors out there. And we will see you guys in the next video.